In this video, I'm just going to provide an example of the last way of expressing the inverse. So let's do an example. So let's say, let f of x equal 2x plus 3, and let f of g of x equal to x. So then the question is, find g of x. All right, so how do we do this? So if you remember from our previous last statement, is that, so f of x is just defined, that's not an issue. It's when we define something this way, when we have a composition of functions, of these two functions, and those two functions are equal to x, we know that f and g are inverses of each other. So if we wanted to find g of x, it's simply the inverse of f. So that's all we have to do. So here we have, oh, let me just put this in green, so it just looks a little bit better when I have it in green. So here we have f of x is equal to 2x plus 3. All we have to do is find the inverse. So y is equal to 2x plus 3. Switch them. X is equal to 2y plus 3. X minus 3 is equal to 2y. Let's do that there. So y is equal to x minus 3 divided by 2. And we know that this is the inverse. So, and we know that the inverse is equal to g of x. So you can write it two ways. First, you can just start off with by saying, well, this is the f inverse, which is x minus 3 divided by 2. But remember, I didn't ask you for f inverse. I asked you for g of x. But we already know that g of x is equal to the inverse. So therefore, g of x is equal to x minus 3 divided by 2. And we are done. Maybe I should, oh, sorry for that, x minus 3 divided by 2, and we are done. And really, I just want to highlight this part one more time, which is if you ever see this, f of g of x is equal to x, it just means these two functions, regardless of the order, I could have said g of f of x is equal to x, these two functions are inverses of each other. All right, I'll see you in the next video where I'm just going to summarize all the ways of describing the inverse.